So welcome to the next talk. We now go to a very specific question that typically comes in many projects for software architects, generic or specific. And we have with Bert Jan Schrijver, someone who probably can give a good help on finding the right answer. So hello, Bert Jan.
Hello.
I hope I pronounced your surname correctly. It's
Pretty good. Yes, thank you.
Where are you based? You're probably in the Netherlands.
Yes, I'm in Utrecht, the center of the Netherlands.
Great. You're a CTO at OpenValue and you have deep experience with Java. I think I heard talk by you at JavaLand and you're at several conferences. But this time it's not specific about Java, but design decisions. And you probably have a better answer. Is it generic or specific than the typical consultants? It depends. You show us on which factor it depends. But you show factors on which it depends, so people can find the right decision to answer the question. So the stage is yours, and I'm looking forward to your talk.
Thank you. So hi everyone, and thanks for joining. In the next 45 minutes, we're going to try to answer the question to design generic or specific stuff. So during this talk, feel free to ask questions or react through the platform chat. To the right of the stream, there should be a tab called Session Feed. So if you click there and type your question or remark there, I may be able to read it and respond to it directly. So let's test this, because I also like to know my audience. So please open the Session Feed tab and type there from which country you're currently watching the stream to know how the audience looks like. So I'm not going to wait on this because there's probably like a 15-second delay before I see your chats. So my name is Bert Jan Schrijver. I'm CTO at OpenValue. I'm also in the board of the NLJUG, the Netherlands Java User Group. So I'm kind of a bit biased towards Java technology. I am a iSAQB accredited trainer for CPSAF, and I'm also in the foundation working group for CPSAF at the iSAQB. So I see the chats flying in, and there's quite a lot. We have people from Germany, from India, let's see, Switzerland. Well, it's too much for me to read. Switzerland, Germany, United Kingdom, well, basically all over the place. Good. Well, now that we know that works, let's get started. So I'll start with a couple of definitions. I'll talk about flexibility in software. We'll talk about different levels where you can apply generic versus specific design. I'll show you some tools to help you decide. We'll talk about the cost of generic solutions, when and why to go generic. Maybe if we have time left, we'll talk about sharing code in an organization, and we'll end with a conclusion. So we also have people from Austria, from Spain, basically all over the place. So let's start with a question to you, and ask this to yourself. We're probably all in some way involved with software development or architecture or software design. So what is software design? If you would need to define it for yourself, how would you define the term software design? Well, if I want to know something, I ask either ChatGPT or go to Wikipedia. In this case, I went to Wikipedia, and Wikipedia said something along the ranks of the activity following requirement specification and before programming. So I love that. It's basically what you do between what you know what to do and actually doing it. Everything in between is design. Or it involves problem solving and planning a software solution, or it's the process of envisioning and defining software solutions to one or more sets of problems. So I'd say basically design is coming up with solutions for problems, and right? So then follow-up question, when is something design and when is something architecture? Well, the next question that you can ask is, does it matter? I think both are about making decisions, significant decisions, where significant is about cost of change. So how significant a decision is, how important a decision is, highly depends on how much pain it brings you when you get it wrong. So, but to dive into this terminology, for me, design is typically something local. So within a class or within a project, and architecture is typically on a higher level, on project level or organization level. And my point that I'll iterate on later is that you can make decisions on generic versus specific on multiple levels. So now we know that what design is. Let's ask ourselves what is specific and what is generic. So a specific solution is tailor-made for a single place, for use in a single place. It's tailored to a specific problem or situation, and may not be easily adaptable to other situations. Whereas a generic solution is a more flexible and reusable solution. You can typically apply it to a wide range of problems or scenarios, and it's typically a generified solution that you can use in more than one place. And place can be anything of class, component, service, application. So to talk a bit more about this hierarchy of places for solutions, I'd like to introduce a concept to you. And this concept is hierarchical decomposition. And this is a practice of basically breaking a system or a problem into smaller parts that are easy or easier to understand. So let's, for example, look at Google. Google search is quite a big product. So if you would look at the top level, you would have one block, looking at the stack of blocks in the background, and the block would be Google search. If we dive one level deeper, there's probably the indexer, the actual search engine, there's ranking in results, there's ads. And if we would then look at the block of the indexer, then the indexer probably consists of something to map out or explore the internet, a spider to follow links, a scraper or parser, etc. So you're basically constantly zooming in on different levels and going from black box descriptions to white box descriptions. So my point is that you can make choices for generic and specific solutions on all of these levels. And this zooming in and out of in levels of detail is a core concept of software architecture, and enables to reason you about and solve issues at the right level. So the C-formal is comparable. It starts with a context view, a high level, which systems do we have around us. There's containers, which is basically web apps, database, etc. Next level is component. Next level is code. So while we're talking about these software design concepts, let's talk about another one. And this is coupling. So coupling, it's relatively easy to define, I think, right? It's the kind and the degree of interdependence between building blocks of software. So how are they related? And it's a measure of how closely connected these two are. So when you change something and something else that you don't want to change needs to change as well, then you have coupling. Low coupling is often a side of a well-structured system. And this is another measure that you use here is cohesion. So cohesion is the degree to which elements of a building block or module belong together. So it measures the strengths of relationships between the pieces of functionality. If a component or building block does only one thing, then it typically has strong cohesion. So usually high cohesion implies low coupling. So these are both good measures of a usable design. So it's also good to know that there are lots of different types of coupling. So a common one is coupling, typically through use or delegation, right? That's something that you typically do. Some class calls some other class. But you can also have coupling through inheritance. You inherit fields or properties or methods from superclasses. You can have coupling via events or messages. So there's messaging or middleware that you use to send stuff. Well, you have logic based on those messages. If they change, you need to typically change both sides. You can have temporal coupling, which means that a component A depends on component B, so that A can't perform its job until B delivers some output. So B needs to go first, then A can go. You can have coupling via data types. For example, in JPA, in database access, there's an entity that responds to a class in a database. If you change something there, then the database may need to change, and the stuff calling this entity may also need to change. You can have coupling via data. So if you depend on specific pieces of data to be present in, for example, a database or something, component A writes to a database, component B reads a field, you can have the same problem. And the most common thing is, I think, on code or API level. So you depend on some piece of code or some piece of API, either a source dependency or a binary dependency in a library. And coupling in itself is not bad. I would say that it's impossible to make a non-trivial system without having some form of coupling. But you do need to be careful with coupling. So I was recently rereading the Unicorn Project, the book by Gene Kim. And in this book, the 5 ideals of DevOps are discussed. So the first ideal is locality and simplicity. So locality is the degree of which a development team can make a local code change in one place, as opposed to having to change it in lots of places. So locality requires simplicity. If you don't have locality, you need to change stuff in lots of places. You have dependencies or you have coupling. And I'd say that dependencies or coupling are the mother of all slowdowns. They prohibit you from moving freely. You can say that they're handcuffs, basically, because they may slow you down. And also realize that any generic solution that you make, any central place where you store logic, you call this logic from different other places, this is coupling. This introduces coupling. So if you copy paste a piece of logic from one place to another place, there's no coupling. It's copy pasted. It's separate from each other. If you have code here, you move it to a reusable component. Let's say here, you move to a reusable component. You have another place, you depend on that reusable component. Now they're coupled via this generic component. So we've probably all learned about clean code, right? And we all know about dry. Don't repeat yourself. So we should never duplicate code or repeat it, and we should always extract methods and have it in central places. So dry increases coupling. It also helps with reusing code, obviously. But my point is that you shouldn't follow dry in a vacuum. So if you have code in one place and you copy it to another place, it's not necessarily a problem. Sure, it is there in 2 places, but I'm going to make an important point to me. And this is that duplicated code, it doesn't hurt you until you need to change it. So if you have a piece of code in place A and you copy it to place B, it's perfectly working fine there. Sure, it's duplicated, but if you never need to change this code, it will keep working forever there. Whereas, and you can also change them independently of each other. So if you would directly move this to a central place and have something else depend on it, and now you need to change something here, it will automatically change here as well. And you may not even want that. So you could say that preventing code duplication can be a form of premature optimization. How do you know that these 2 pieces of code are actually the same and that they will evolve the same? And on the other hand, if you copy a piece of code from A to B and you need to change it, you need to do a bug fix or something, it's probably not that much work to fix it in 2 places. There's like regex, search replace, all kinds of tools that can help you there. So I'm not saying that you should never extract generic methods. I'm saying that you should be careful about it. You may not agree with me on that, and that's fine. I'm just sharing my opinion. So we often say that design is about making things future-proof. But isn't that as simple as asking, can we predict the future? Should we be prepared for future changes? Sure, but last time I checked, we weren't that good at predicting the future. So how do you make code easily prepared for future changes? So design should be structured to accommodate change. So how do you make code easily changeable? Well, we can be prepared for any future change by making the code as simple as we can. So it can be easily changed, but since we have no idea what the future will bring, no such thing as future-proof exists. The only thing you can do is making code really simple. So when I'm thinking about making decisions, I'm often thinking about the risk of the wrong decision. So if I'm making a foundational decision, like I'm going to build a house and I'm going to build the foundations either out of wood or out of concrete. I'm going to build my entire house on this. Is a year later I figure out, oh, it's better if it would have been concrete instead of wood. Well, it would have been a lot of work to fix or to change it, right? So if the risk of a wrong decision is high, I tend to think longer about decisions. If the risk of a wrong decision is low, if it's like only like the chimney on the house, where the smoke comes out, that's relatively easy to change. Still, you still need a crane, you still need to lift it off, pick a new one on there, but it's less work than replacing the foundations of a house. So, well, since we don't know what the future will bring, no such thing as being future-proof exists. And I have an example to explain it. So I joined the project a while ago, and this was a project for a government organization. So it was a tender. I think the German word is Ausschreibung. So a government organization needed a system. It had asked lots of companies in the market to build it, and the company where I worked had won it. And I joined this project, and this project was already in heavy weather. So what was going on there was that it turned out that the system was fairly well complex to build. So why was this? Because there were loads of configurable things in the system. And the reason for this was that the people who had designed this system, they were information architects hired by the government. And their experience was that software was hard to change. So once software has been delivered, their experience was it is hard to change. So how do you, well, prevent this to have software that is hard to change? Well, it's easy. You make it really flexible. So what they had done is every screen that had fields on it, you could change the fields there via an admin interface. So you could change all the labels, you could add extra fields, you could add extra values in drop downs, etc. It was really super flexible, this system. So when I joined there on my first day, I opened the system and it was a bit slow to just load the home screen of the system. So I asked to my colleagues, like, why is it slow? What's going on? Yeah, it's doing a database query, he said. So, okay, fine. I know a thing or two about database queries. Let me, can I have a look at the query? Maybe can you print it for me so I can have a look at it? He said, yeah, I can print it for you, but are you sure? I said, yeah, sure, print the query for me. So he says, okay, I'll be back. So he walks away and he's gone for like 15, 20 minutes. And it's like, what's taking him so long printing this single query? So he comes back with a stack of paper about this big, right? And it's like, what is this? Yeah, that's the query you requested. So it was like, I don't know, 7,000 lines of SQL code, all kinds of queries combined. And it was a huge complex model because of all those extra fields that you needed to fetch for all those screens and list values and ever. It became really, really complex as a data model. And this is why it became slow. And because the data model was so complex, in the end, the system became hard to change. So it was kind of like a self-fulfilling prophecy. The architects who had the experience of software that was hard to change designed a really flexible system. And as a result, the system became hard to change. They basically dug their own grave. So you may ask, how did you solve the problem? Well, we solved the problem by convincing the customer that this wasn't going to work, that we needed to start over with something really simple. And in the end, we built a really simple system in a couple of months that did exactly what the customer needed. No extra configurable flexibility stuff, just really simple code, and that code became easy to change. So I'd like to share a quote from unfortunately, the late Stefan Tilkov. Stefan was an amazing human, and he once said that highly specific code is often preferable to sophisticated configuration. So to have really specific stuff, it often works better than having really sophisticated configurable stuff. And you can apply the same wisdom to making choices for generic versus specific. So we're in for a good 20 minutes now. I haven't talked about generic versus specific yet. Let's start. Let's start with levels. So you can apply those design decisions that we're going to talk about in a bit on lots of different levels. Generic versus specific on a code or a class level, share a class or not. You can apply it on having manual code versus generated code. Is it a problem if you have duplicated generated code? Well, it's generated, so I don't really mind. On a library level, are you going to use a library or not? Using a library versus building yourself, extracting generic logic to a reusable library. On a data level. So I have a interesting experience with larger organizations and data models. So a question that you can always ask is, should we have a generic shared data model in the organization, a canonical data model or not? So I remember doing software for insurance companies, and then there was this standard, a generic standard. It was called GIM. And GIM stands for Generieke Interface Manager, which basically means Generic Interface Manager. So that's an abbreviation of 3 words that contains 2 words that you always should be very careful. So it has generic and manager, and both are a recipe for trouble. So the generic interface manager was a data format that was used to exchange data between insurance companies and intermediaries selling policies and quotes for insurances. So this was in general a nice idea because you could build the integration once and then send data to lots of different insurance companies. But every now and then you would have a field or a piece of data that wouldn't fit in the data catalog that was described by the people from that were making the standard. So then you had to call CV, the Standardization Institute for Insurers, and then someone picked up and you said, well, I have this field, this piece of data, and I cannot find any field where to fit it in the data model. And he said, yes, you're right. But okay, so what's next? Well, we're going to make a new field to put this data in, and then there's a review period of 3 months, and then there's a release period of a month, and then we release a new version, and then it typically takes 6 to 12 months for all companies to adapt to the new standard. So I'm like, so in 2 years from now, we can use a new field. And he said, yes. I said, okay, thank you, hung up. I don't have 2 years to wait. So what we instead would do was talk to the insurer and say, okay, well, let's misuse this other field, put the data in there and agree that we're using this field for the wrong thing, but at least we can translate the data because then we can have it in production in 2 weeks instead of 2 years. So this is the problem with those generic data models. They make you slow because any standardization makes you slow for a reason, because standardization is not easy. So you can talk about generic for specific on a service level, like a microservice level. Are you going to solve stuff like an interface between 2 services? Are you going to make this generic, so extract the data classes, or specific? How do you handle security, for example? So are you going to have a piece of security code copied in every service, or are you going to use a generic library? Or are you going to use the sidecar pattern, where security is basically a proxy that gets deployed next to your microservice? And you can also talk about it on organization level. So when to do something specific for a project, or when to go generic on an organization level. How do you share code between teams? How do you maintain generic code? What's the life cycle of generic components? So sharing code between teams is nice, but it also increased dependencies. And these are dependencies between teams. And dependencies between people are even worse than dependencies between software. But because people have different agendas, different priorities. Yeah, I want to change something in this generic component, but it has impact on multiple teams. Well, the reason why you want to change this is not a good reason for the other team. So we'll put it in our backlogs in 4 weeks from now. But I want it now. Yeah, you just need to wait. So the questions that we're going to answer right now live on all of these levels. So how do you decide whether to go for a generic or a specific solution? I'll give you some tools to help you decide. So the first question you ask is, do we really need this now? Or you ain't gonna need it yet. So if you think about genericizing something, ask you the question, do we really need this now? In object-oriented programming, if you have one concrete implementation for a concept, should you put an interface in between and talk via that interface to the component? It depends, right? So you can call the component directly. Yeah, but then I cannot swap it for something else in the future. Well, if there's only one, and at a later point you have a second instance, then probably you can then decide what the generic interface will be, right? If you put one in between right from the start, you may choose the wrong abstraction there. The 5 W's. Love this one. So the 5 W's, the first W is a why. So somebody wants something, why? The second is why. The third is why, the fourth is why, the fifth is why. So I want to make this generic component. Why do you make it? Because then it's reusable. Why do you think it's good to have it reusable? Because then we have this code in only one place. So why is it better to have this code in one place than having it copied? Because it makes maintenance easy. So why is it important to make easy maintenance? Because we're going to change this a lot. So why do you think we're going to change this a lot? Yeah, I have no idea. Okay, then maybe it's not a good idea yet. Think about time and effort for generic versus specific. So there's a fallacy. So something is typically thought that's often wrong. And this is that a specific solution requires more work in the future if a similar requirement is needed. Well, there's also the myth of the first time right. So you're probably not going to get your solution right the first time. So how good are you going to be at building a generic solution the first time? Maybe you want to experience the problems first. About time and effort, if it's something you're going to use in 20 places, sure, it makes sense to build a generic pretty much from the start. But if there's something that you're only going to use in one place, it doesn't make sense to make a generic solution. If it's something that you're going to use in 2 places and not any other place in the future, well, then maybe making something generic is also not worth the effort. Think about in complexity and scope. So if the problem is well defined and has a limited scope, a specific solution may be more appropriate. If the problem is complex, has a wide range of potential scenarios, a generic solution may be a better choice. The rule of 3, we're going to look at that in a bit. And also think about future needs and evolution. So you need to think about how will this change in the future. If you think it's something that's going to change a lot, okay, then maybe a generic solution may help to adapt to these kind of future changes. So my friend Gunnar Morling said it nice, and he said, a fair share of software design is professional procrastination. So keeping options on the table, doors open for as long as you can, in order to avoid locking yourself into a corner by committing too early to abstractions which turn out to be poor later on. And I think this is one of the key reasons why you shouldn't go generic too soon, because of the risk of choosing the wrong abstraction. We'll look at that in a couple of minutes. So the rule of 3, this is not my rule. I don't remember who came up with it, but I've been using it for a while and I love it. Rule of 3 is if you reuse code, copy it once and only abstract the 3rd time. So first time you write it, second time you have the same problem, you copy it, and not the 3rd time you have the problem, or only the 3rd time you have the problem, you start making abstraction. This helps you avoiding writing the wrong abstraction. So it's easier to make a good abstraction from duplicated code than to refactor the wrong abstraction. So you can probably also call this 3 strikes and you refactor. So the first case of a problem, you just build it. Don't genericize it all. Solve the problem in front of you. You ain't gonna need it yet. The second case, duplicate the original, redesign it a little, and extract some common behavior while you change. Think about these things are common about these use cases, and these are not. So once the 3rd case comes in, look at the lessons from the first 2 passes or the first 2 implementations, and then design a generic solution based on the first 2 that will make it easy to add your 3rd case. So one tool you can use is design heuristics. So the first pass is you apply YAGNI in the rule of 3, as simple and specific as possible. Then a second pass based on your knowledge of the solution domain, so how the solution looks, is a generic solution less work? If so, it may be a good idea. And the 3rd pass based on the problem domain, so how actually the problem space looks, is the easiest solution that we can come up with actually the correct solution? And then the 4th pass, looking at customer behavior or other maybe non-technical considerations, does this change your decision? So you maybe can reinterpret YAGNI as avoiding unnecessary work, right? So another tool you can use to help is strategic design. And a strategic design is a concept from domain-driven design. And it's a tool to help you decide for generic or specific. But I think it's more about building something yourself or not. So strategic design identifies 3 subdomains from the perspective of custom software development. So the first one is your core domain. A core domain is something that makes an organization special and different from other organizations. An organization cannot succeed without having their core domain and being really good at the core domain. So because it's so important, this should have complete focus. You should build this yourself, have your best team work on this, because without this, your organization cannot function. Then you can have a supporting subdomain. So that's a subdomain that's necessary for the organization to succeed, but it's not in the core domain. So it's not generic because there's still some kind of specialization for your organization, but you may be able to start with an existing solution and tweak it or extend it to your specific needs. And then finally, a generic subdomain is something that does not contain anything special to your organization, but you need for the overall solution to work. So you can save a lot of time by trying to use off-the-shelf software for generic subdomains. For example, identity management or invoicing or billing or stuff like that. So don't build this yourself. And then Conway's law. So Melvin Conway said that organizations design systems that mirror their own communication structure. So another tip or tool is that you shouldn't force a solution that goes against the organization structure. So for example, if 3 teams don't want to work together, you should be careful about forcing a generic solution on those teams, because probably they don't want to work with it or they don't want to use it. So an example for this is I used to work at an educational publisher, and at this publisher there were 3 basically business units. Primary education, so from 4 to 12 years, secondary education from 12 to 18 years, and professional education from 16 to 20 years, something like this. And they were all working independently from each other, but they all wanted an e-learning system. So they asked the IT department, can you build me an e-learning system? And then the IT department, saw the risks there. So you can either build 3 complete separate systems, but then you're reinventing the wheel 3 times. If you build one generic system, you're going to be in trouble because those 3 business units probably have different priorities and different wishes for requirements. And if, I don't know, primary education goes down because somebody in secondary education is doing a DDoS on the system because they don't want to make their exam, well, then they're going to have a fight as well. So in this case, it is essentially 3 times the same system, but because the organization was in 3 parts that didn't work together that well, it's probably not going to work to build everything generic. It is probably going to work to build everything specific, but that will be a lot of work. So in this case, we kind of find a middle ground. Every business unit had its own code base with its own specific look and feel, but we set up a team to build generic components that the other teams could reuse. So if you look at the cost of going generic, what does it cost you to build a generic solution? Well, going generic may save time in the long run, but what is the price you pay? I'll introduce another rule of 3, and this is that building reusable components is 3 times as difficult as single-use components. So the price you pay is coupling, both on a code level, so pieces of code are coupled, but also on a people or team level, if multiple teams need to work on the same generic solution. So what if you get it wrong? What if you make the wrong choice? Well, if you get it wrong, you typically have made the wrong abstraction. Making stuff generic means abstractions. And there are no zero-cost abstraction. So everything you abstract, it has some cost or pain. So making something generic, that's typically clear. But how about building a generic solution and then onboarding new people? They look through the code in their own project-specific code, and then they see a piece where some kind of external library is called that's maintained by another team, and they come look at the code of that library. Takes extra time. Readability. If all the code is in one class, then you can easily read through it. But if you need to jump back and forth from shared classes and libraries and REST endpoints and whatever, it makes it less readable. Coupling. We talked about that a lot already. So if you write bad abstractions, well, then you're writing unnecessary reusable code. You're introducing unnecessary coupling. That's still, it's bad, but it doesn't cost you that much. But maintaining bad abstractions, they may be hard to see, they may be hard to understand, and they may be hard to extend. So it's even more difficult maintaining those wrong abstractions. So when or why should you go generic? Well, we'll start with the bad reasons first. First one is we've always done it like this. And that's why we all make everything generic. Well, that's never a good reason, right? We don't want to depend on libraries. Interesting. So there's an open source library that's used by thousands of companies around the world, and instead we're going to build our own stuff because we don't trust the thousands of companies that use this library. We need to be future-proof. Well, we're pretty sure that we cannot predict the future. So the only way to be future-proof is to make really simple code, and a generic solution may not be the simplest solution. Because the product owner wants it. Well, the product owner can tell us what they want, but not how we're going to build it. It's a responsibility of the team. And then my favorite one, because the architect wants it. So a team needs to build something, they need to build it, maintain it, operate it. And an architect says, I want a generic solution. Because looking from a distance, it may look fine to have a generic solution. So this looking from a distance, I like to call this seagull architecture. So with seagull, those birds you see fly around the sea. A seagull architecture is when an architect flies high above the developers, every now and then flies down, shouts, drops their shit on the developers, steals their French fries, and flies back up again. This is seagull architecture, only dumping stuff and even stealing their food, right? So the problem here is that the shit is only going down, while the shit should be going up as well. There needs to be a feedback loop of what the architect is doing and how this is working for the team. So whenever somebody does this, they fly by, they drop shit on you, you just say seagull architect. They probably don't know what it means. Then you can explain it, and hopefully you can get a discussion going about feedback loops with the team. So valid reasons to go generic. First one, the rule of three checks out. So it's the third time, now I'm pretty sure I can make it generic. Or you are pretty sure you're going to need it almost everywhere. Security, logging, metrics, those kind of cross-cutting concepts. Maybe a library that a lot of teams will use. It's a library we use to send logging to our centralized logging system. Okay, makes sense to have. That's also something that you're going to use pretty much everywhere. This is an interesting one. So complex skills, complex logic or skills that only a couple of people have. Let's say that your company is doing a lot with encryption. Not everyone is, including me, is competent in writing encryption algorithms. So if you want to prevent that people are doing this all by themselves, maybe you're saying, okay, the only way you use encryption in this company is if you're going to use this library that we develop in-house with people who do have the skills to write encryption code. So here you're using a generic solution as encapsulation around a piece of complex logic to make sure that only a couple of people can edit this. And when the gains are bigger than the cost, obviously, then when it's clear that it's a lot cheaper to do a generic, then by any means go generic as well. So think back about those layers in hierarchical decomposition. There's a code, there's a component, there's a service. And ask yourself, are there considerations for going generic or specific the same on each of those levels? Is making the wrong decision on a class level the same as making wrong decision on an organization level? Or I should say no. The risk of when getting it wrong is higher when the level is higher. So if you make a wrong decision on generic for a specific on organization level, multiple teams are going to be in trouble because of this. If it's local on code level in one team, it's only this team, maybe only one developer. I think we also should not confuse generification with standardization. So it's fine to standardize. You can standardize on we're doing, I don't know, OAuth everywhere. That doesn't necessarily mean that you need a generic OAuth library to write in your organization. Maybe you can use something off the shelf. You can also say we standardize on REST in our organization. That doesn't mean that you need a standard REST library and do everything with, I don't know, Java and Spring. If you standardize on REST, then you can still have specific implementations in different parts of your organization. So having standards on how to approach stuff doesn't mean that you should solve this in a generic way. You can still have specific implementations of standardized approaches. So let's dive a little bit into why I think that specific is often faster. I'm going to tell a couple of experiences and stories. We're going to start with a little hobby of mine, and this is code challenges. So code challenges typically challenge you to solve some kind of problem, right? So the first one is code golf. And this was at the Javaland conference. And what you need to do is, in the least amount of characters of code, solve a problem. The problem was to validate a German bank account number, something like this. I was one of the first to solve the initial solution because I made an application that logged the parameters where the test code was tested with, sent this to a remote server and optimized for the specific test cases in the challenge. So the guy who was organizing this found out, added lots of more test cases, and I was out. So lots of people who were doing smart stuff with bit shifting were way shorter than me in terms of characters of code. But in my case, I still got an honorable mention because I wrote a client-server application in less than 100 characters. So I did something like java.net url.read byte, and then on that URL, I could implement it myself. So in this case, I was the fastest initially because I had made a very specific solution that only gave the right results for the test set where this was applied. So another one is the Advent of Code. And the Advent of Code, it starts, in a couple of days. It's a challenge where from 1 December till Christmas, every day a new code challenge arises. And it's fun to participate in. It's technology independent. So you typically get problems like this. In this case, you get a description of textual description of a couple of stacks of crates. So you see them in the bottom here. There's stack 1 with a crate with a letter N and Z, stack 2 with a crate D, C, and M, and stack 3 with a crate with a P. And then there's instructions. So move one crate from 2 to 1. So you're going to move N on top of stack. Let's see, you're going to move D from 2 to 1, and then you're going to move 3 crates from stack 3 to from stack 1 to stack 3, and in the end you need to figure out what the end result will be here. So my initial thought was to solve this generic. Sorry. So example input here was this. It's a bit more complex than the example. So I saw this and I saw, okay, I need to make a generic matrix parser because there are matrices here and I can easily move them. And I start writing all this code and generic matrix parser that I could use to parse the input, etc., etc. And it took me an hour. And then a colleague solved this like this. And he basically said, no, there are like 7 stacks and I can hard code them. And there are error lists because, and they're even, the code is not even aligned and there are spaces missing here and there. This was a way faster solution. So this is, I think, a good example why specific is typically a lot faster for the first implementation. To give a counterexample, there are also cases where generic can be a lot faster. So think about how you handle exceptions in a Java or Spring application. You could write an exception handler for every endpoint or every screen, but you could also do something like this. So this is a Spring AOP class where you add an exception handler that wraps around all your endpoints, and then you get a default error handler. So you only solve it in one place. So it's a bit harder to find, but it's also a lot faster. A final example is website code reuse. So we have lots of websites at OpenValue, but my favorite one is openvalue.cat. So this is a site where we have all our cats. And we're currently in the 3rd iteration of this site. So the first version was the simplest thing that could work, hard-coded HTML. Then the second case, we found that people were regularly updating their cat pictures. So we then refactored it to a somewhat generated site based on cat definitions. So now we're ready to launch our next site, which is openvalue.dog, which has a list of all our dogs. But because of the rule of 3, we'll copy it first, replace the pictures of dogs, etc. And not until we make our 3rd animal website, we'll build a reusable, OpenValue animals website component. So we're going to skip the bonus topic to have some time for questions. And to basically wrap up here, to summarize the topic, should you go generic or specific? Well, you can consider a couple of things. You ain't going to need it, the rule of 3, the 5 Ws. You can think about the cost of going generic. Is it cheaper or not? Also in terms of maintenance, etc. You could think about the scope and level of solving stuff, specific or generic. Think about Conway's law and don't force generic solutions to an organization who doesn't want to work generic. And think about impact on the organization. So should you go generic or specific? Well, we had the question in the beginning, and unfortunately or fortunately, the answer obviously is always it depends. Right? So overall, it should be a careful analysis of the problem or scenario and its potential future needs and evolution. It's always a trade-off, but I hope that you now have a couple of practical pointers to apply the next time you face a decision. So in the end, it's not necessarily about getting it right from the start, but getting it right in the end. Because a program that works perfectly, but is impossible to change, will become useless over time. Whereas a program that does not work, but is easy to change, it will become and remain useful continuously. So if I need to give you one piece of advice that I hope will stick, it is write simple code. That's it. I hope you can apply your newfound knowledge the next time you need to make a decision. So I'm happy to take any questions that we may have.
Yes, actually we have. Thanks for the talk, Bert, and thanks for helping us on finding the right decision. Actually, there's not only a question, there's a question that already started kind of a small discussion, to say it like it. And it's about the rule of three. How does the person who implements the third version know about the first two implementations? He can only do the right decisions if he knows about the previous implementation.
Yes. Yeah.
First, answer the question, then I will come with the answer from the audience.
Yeah. Well, that's a great that's a great question. So, and this depends also on what level it is duplicated, right? So, if this is within one project and within one team, then chances are that there will be somebody alive and present at the team at some point where they know that this is already there. If it's bigger in an organization, well, hopefully there are mechanisms where you discuss designs and challenges with other developers or other architects, saying, have any of you solved this problem before? If it's a huge organization, like, I don't know, 2,000 developers, then you can be pretty sure that the wheel will be reinvented in multiple places, right? So I think there are two ways to approach this, or three ways. First is to talk to people. Second is to start searching through code bases. And third is to basically have some kind of inventory of reusable components or problems we have solved somewhere here and there. But I think it's definitely a knowledge and communication challenge. But I'm curious to hear what solution came from the audience.
Mm-hmm. No, it's a kind of a follow-up question. If the third person does not know a thing about done elsewhere, may this not be a hint that you should not start caring about code that he never heard about? So,
Yeah.
So the transparency about it's also in contrast. There should be transparency about cross-cutting concerns, really used everywhere. So.
Yeah. No, I agree. And I think there's a difference between cross-cutting concerns that you use everywhere and a solution that you, I don't know, have in one or two places. So if you don't know it's already solved in two other places, then you can also not make it generic. So Michel comments that he hopes that the first two implementers documented the why of their choices. Yes, because any choice at any point of time is the result of hopefully a careful consideration of the context, pros and cons, different solutions, and making a choice. And for this, obviously, there's architecture decision records or in general documentation can help.
Mm-hmm. And there was another comment more that I agree with most of what you have said, or if you replace the word generic with the word shared.
Sure.
So because you can and should be generic in a very specific context.
Yes. Well, I think then we're talking about semantics of word, but yes, generally,
Yeah.
wherever I said generic, I mostly mean shared code. Obviously, you can have in a specific solution a generalification of a problem. But well, the semantic difference between those two goes a bit behind the scope of this talk. But in general, whenever I say generic, I mean shared. Yes.
Mm-hmm. And then there was, I think it's a follow-up also, you had this with the library of the encryption. If there's a simple solution needed in several applications, it's better to generalize it as a single library, or generalization is important only for complex solutions.
No, I think for simple, sure. And it depends on what you want to do in terms of maintenance. So if you depend on some open source library, then every team can have their own like a life cycle for this library, like upgrade it whenever they want, etc. If you centralize it inside your company, then well, you need to think about, if I make an update, am I going to force this to others or not? Am I going to make it mandatory to use this or not? So generalizing stuff, simple stuff that's used everywhere, also comes with some organizational responsibilities and thinking about life cycles, updates, etc. But in general, for me, it doesn't really matter whether it's a simple thing that's used everywhere or a complex thing that's used everywhere. Simple thing can be used as well. To give a counterexample, there's this Node.js package that's called LeftPad. That is 3 lines of code that allows you to add like zeros to a number. Well, this broke the internet a couple of years ago because somebody unpublished this. So maybe you should make generic solutions for adding zeros to a string within your company.
Yeah, that was a big wave. Actually, we wrote about it as well, and there were some follow-ups. And I think that they changed a lot of things within all those package repositories for JavaScript and Python as well, where there was similar incidents there. Yeah. Thanks a lot. Was very good talk. We learned a lot. I really keep the word Seagull architect, which does not only work for architects. It's, I think, for all hierarchical structures.
Yeah, it obviously it stems from Seagull managers, right? That's where it's come from. But I like to apply it to architects as well.
Yeah, that's very good. Thanks very much, and thanks for the talk.